Hello friends! Before the video starts, I'm just going to point out that this video is based on AP topics 1.5 and 1.8, which are atomic structure and electron configuration, and valence electrons and ionic compounds. And with that, let's begin. So, on Roblox, there lies a game known as Soul's RNG. Honestly, in my opinion, it wouldn't be fair to call this thing a game, because there's pretty much no game to be played. I think there'll be a clip on the screen while I talk about this, but pretty much, in this quote-unquote game, all you do is roll for these auras, which is essentially just titles with special effects when you equip them. Some of these auras are extremely rare, some being 1 out of millions to get. And although this idea of a game seems pointless and too simple as a game, this game is ridiculously popular and at times reaches over 100,000 players. I don't know if it's the idea of gambling for free or the special effects or the little rushes of dopamine kids get when they roll something rare, but this game has recently become extremely successful. And so I decided to copy this game, but instead of auras, I've used every single element on the periodic table. Here, let me show you. So, as you can see on the left side, we have a dictionary, a references section, an inventory, and a tutorial. This game really does not need a tutorial because you're literally just going to be pressing the same roll button over and over again. But just for educational purposes, I'll be going through the tutorial. So pretty much each element's probability is based on the amount of protons that it has. For example, helium, which has 2 protons, would have a 1 out of 2 chance of being pulled. On the other hand, an element like iron, which has 26 protons, would have a 1 out of 26 chance to be rolled. To differentiate a bit, each period on the periodic table has a different color, as shown by this table right here. Oh, and the best part, if you don't understand the vocabulary in the tutorial, you can always just reference the dictionary. Anyways, back to the tutorial, it also says that when you equip an element, you can see yourself holding the amount of protons, the neutrons, and the valence electrons that your equipped element has. I'll show an example on the screen right now. And if you caught it, you can also see that the inventory also displays an element's protons, neutrons, electrons, valence electrons, and their electron configuration. And for those still wondering what these are, protons are the positively charged particles that are located in the nucleus of an atom. They determine the atomic number of an element. The neutrons are the particles located in the nucleus of an atom that have no charge. They determine the isotope of each element by changing the atom's mass. Electrons are the negatively charged particles that can exist orbiting the nucleus of an atom or just unbound. The removal and addition of electrons change atoms into ions. Valence electrons are the bounded electrons that exist on the outermost energy level of an atom. They're the easiest to take off when you're trying to ionize an atom. An electron configuration is a form of identifying an atom or ion based on the arrangement of electrons in the particle. And now the final part of the tutorial, ionization, which you can do by pressing this button right here. After pressing that, you would then have to try to pull out the electron by continuously pressing this button right here. And just like real life, helium's electron is much harder to pull off than hydrogen because its outermost shell is full, which is ideal for an atom. For the other atoms, you would be able to tell how hard it is to pull off an electron based on Coulomb's law, which relates the force of attraction and the radius of each atom. And that about sums up what's in the tutorial and pretty much all of the gameplay. To finish off this video, I'm just gonna have a time lapse of me rolling about like 100 elements just to see what I get. Also, here's the references, and thank you for watching, I guess. Bye. Ooh, let's see what happens if I give myself every element. Oh geez, it's lagging. Okay.